In this question, they say that the number of lateness of Albert in a month follow a Poisson distribution with mean 1.8. We let the random variable be x, and then x follow a Poisson distribution with the mean 1.8 here. After that, in part A, the question defined that an event good, which means that the number of lateness is less than 2, which is equivalent to x may equal to 0 or x equal to 1. So the required probability is equal to the number of lateness equal to 0 or the number of lateness equal to 1 by using Poisson distribution e power -1.8. The first case is something power 0 divided by 0 factorial. And the second case something power 1 over 1 factorial, which is 1.8. We get 0.462836887. In part B, they are asking there are two schemes, and then you expected that two schemes will give different bonus in different situations. And then imagine that you are Albert, you have to choose one of the more favorable suggestions here. You need to know is about our criteria. How we distinguish which suggestions is better for us is depends on the expected value of the bonus. Therefore, we are going to calculate the expected bonus for suggestions 1, and then we try to calculate the expected value of bonus for suggestions 2. To get the value of expected value, we have the outcome. What is missing is the corresponding probability of each outcome. And here we use y to represent the number of months with good performance, while x is already occupied for the number of lateness within a month. So we have some preparation work and we have the strategy. Now we are going to start calculation. In suggestions 1, expected value of bonus is equal to 5,000 times the corresponding probability. 2,500 times the corresponding probability. The corresponding probability to get 4 good performance. You have to identify what kind of distribution is y. Y is the number of good performance among 4 months. So y following a binomial distribution. We repeat the same thing for 4 times, and the successful rate is 0.46 something, which is the answer in part A. Therefore, for easy presentation, we take the value A is 0.462836887, while B is equal to 1 minus 0.462836887. We use A and B is because it's consistent with our memory slot in calculator. A representing the success probability, B representing the fail probability. So, the corresponding probability to get 4-month good performance is A 4 times in a row. And then the probability to get 3 good performance out of 4 months, it is 4C3, success 3 times, fail 1 time. The case that we have 2 good performance, among 4 we get 2, successful time, fail 2 times. To get 1 month only, among 4 we get 1, success 1 time, fail 3 times. And the last term times 0, so just simply plus 0. We get the expected value for the suggestions 1 is 14905055464. And then we are going to repeat the same thing for suggestions 2. While this one is easier, only 2 outcomes. The first outcome, 8,000, and also multiply the corresponding probability. The requirement is the total number of lateness in this 4 months. So we are not talking about number of good months here. We are talking about the total number of lateness in 4 months. However, X that we labeled before, it is for each month. in a month only. So pay extra attention that this is not exactly the same as x. Maybe we can label it as x4. That follow a Poisson distribution with the mean 1.8 times 4 times because the period is 4 times of the original one. That means a Poisson distribution with the mean 7.2. Therefore, the criteria here is talking about x4 less than 5, while the calculations are really similar. You better separate them, make your hand busier than your brain. And before you finish it, make sure you double check once again. Should we include the case that x4 equal to 5? We do not include that here because we say fewer than 5. So it's equal to e power negative 7.2, and then we have something power 0 over 0 factorial, something power 1 over 1 factorial, something power 2 over 2 factorial. And then we write down 7.2. A clear step will definitely reduce the chance to get wrong answer. We get 1244 something. After we compare the average benefit for each suggestions, we find that given the same situation, we can get more on average from bonus 1. So the suggestions 1 is more favorable to Albert, since it's smaller than expected value of bonus 1. Therefore, suggestions 1 is better. Don't forget to make the decision and then answer directly what is asking in the question. Now we go to part C. In part C, they give you another new event, which is independence, totally independent to the number of neighbors. It's about the issue of early leaves. There is another Poisson distribution with mean equal to lambda. And what it's asking in C1 is in terms of E and lambda, we have to find the probability that Albert is late for 2 times and does not leave early. For easy reading, we better translate this into standardized mathematical expression. They say the probability that Albert is late in one single month, so refer to x here. Late for 2 times, that means x is exactly equal to 2. And intercept does not leave early in a certain month, so we better let another random variable for the number of early leave. We let L be the number of early leave in a month. It's important to state the period clearly. And then we know that L follow a Poisson distribution with the mean lambda. And the requirement here does not leave early. That means the L is equal to exactly equal to 2. We are finding this probability. In part C1, they are asking for this, and because they say 2 events are totally independent, so this is equal to 2 separate probability multiplied together. First, to fulfill this requirement is e power negative 1.8 and then 1.8 power 2 divided by 2 factorial. And then multiply. This is e power negative lambda. And then we have lambda power 0 over 0 factorial. 1.62 e power negative 1.8 and then also time e power negative lambda. So you may write 1.62 e power of negative 1.8 minus lambda because they say in terms of e. That's why I didn't change this part into decimal format. Now part 2. We are asked to find the conditional probability given the situation is like this. The sum of the number of lateness and early leave is 2. We have to find the probability that Albert is late for 2 times and does not leave early in that month is 0.36. We have to find lambda. So they give us an equation and then we are going to solve it. Once again, when you analyze how you can solve it, you better translate the item expressed in mathematical format. The first item given The total number of early leaf and also lateness is 2. That means x plus L is equal to 2. And the probability that Albert is late for 2, that means x equal to 2. At the same time, L equal to 0. They say this probability is 0.36. Even if you have no idea how to handle it, at least whenever you find a conditional probability, you are going to apply this law. X is equal to 2 and L equal to 0. The first event and x plus L is equal to 2. These two events at the same time divided by the given condition. Now the problem is how you can simplify here. And you will find that this is more strict than this requirement. If it is like this, then their total is equal to 2 is a must. So this is useless. It's just simply talking about x equal to 2 and L equal to 0. That's the only constraint in this situation. If you remember, this is exactly what we find out in part C1. So the only problem is here. How can you calculate this? This is one of the case. So you should list out the case. X equal to 2 and L equal to 0. This is the first case fulfill our requirement. Then the next case is x equal to 1, L equal to 1. The last case, x equal to 0, L equal to 2. So basically this probability is talking about among this path. This path come up, the probability is 0.36. Our denominator here is consists of two paths. The first path is exactly the same as numerator, we calculate already. The second path is x equal to 1 and L equal to 1. The last path is x equal to 0 and L equal to 2 at the same time. Now it is very clear what we have to do. Just express everything in terms of lambda. This part is e power negative 1.8 and then we have 1.8 power 1 over 1 factorial. Together with e power of lambda, negative lambda, and then lambda power of 1 over 1 factorial. The last part is talking about e power negative 1.8, 1.8 power of 0 divided by 0 factorial, and then e power negative lambda, lambda power of 2 divided by 2 factorial, and the whole thing equal to 0.36. You better tidy up and simplify first. Even though it's look a little bit complicated, we still find that there is a common term. So the most complicated part is repeated in every term, so we can just cancel out. We have 1.62 and then plus 1.8 lambda term and then 1 over 2 lambda square term. So it's a quadratic equation, then you can solve lambda easily. By using formula 1, we get lambda equal to 1.2 or lambda is equal to negative 4.8. But the average can't be negative, so it is rejected. Therefore, lambda is equal to 1.2. In your exam, you think that if it is too complicated, too many things together, I would suggest you to break down your process and then you just focus on this part, evaluate it, break down this part, evaluate it, and then put them together finally. But again, read the word very carefully, spend more time, stay calm, and then set up the strategy before you really move your hand is far more important.